my dear students, JSS3 in particular. I hope you are well at home, listening to my voice from our online classes. And last week, we rounded off a topic we started for weeks: energy, work, energy, and power. And I gave you assignments. I don't know if you get that assignment, but before I go to this new topic, I want to do correction for you so that if you get the answer, you will know. The first number says a man of 50 a man of mass 50 kg. A man of mass 50 kg. He said ascends a flight of stairs 5 meters high in 5 seconds. If the acceleration due to gravity g is equal to 10 meters per second squared, calculate the power at the power of the man. I told us last week that power is equal to work done all over time taken, or energy expended divided by time. It's the same thing. Now remember that I told us that work done is equal to F dot S. That is force times perpendicular distance moved, then divided by time. Then, if you look at what you are given is still mass. Remember that I told you that F in physics, F, which is force, is equal to what? MA, mass, times acceleration due to gravity. And now narrowed it down to where you will now follow it. Because we are not giving force, we are not giving work done. But from these formulas, we now can get to where we are going. So if F is equal to MA, we know M now as 50 kg, we know A, which is the same thing as what? G, acceleration due to gravity. If you don't call it A equals G. And it's equal to 10 meters per second squared. Then all over T, all over time. So finally we have our MA as 50 kg. Acceleration is 10. Then remember that the stairs are 5 meters high, which is now S, distance, S. Multiply by 5 all over time, which is 5 seconds. So if I cancel out, I will have 500 watts. 550 times 10, which is 500 watts. So that is our answer. The next question there says, a boy weighing 350 Newton runs up a flight of stairs consisting of 20 steps, each 10 cm high in 10 seconds. What is his power? If you look at number 2, you see that what they are giving is force. The boy weighing a boy weighing 350 Newton. Now what is that is equal to what? F. Force is measured in Newton. And then the stairs, we have 20 stairs. 20 stairs. Okay, 20 steps. 20 steps. Each 10 cm high. 10 cm high. Then remember that T time equals 10 seconds. There is power equals, remember power again, P is the same thing as work done multiplied by time taken, divided by time. Sorry. And we know that work done is equal to force multiplied by distance all over time. We are giving force now. We will not go to find mass because what we are given is force, which is 300 Newton. We now begin to calculate. Our F is 350 Newton. So in force, acceleration due to gravity is there. Because F is equal to what? Mass and then acceleration. Don't put acceleration due to gravity again. It is already in force. So force is equal to ma. They gave us force. What it means that here, it is made up of mass multiplied by acceleration due to gravity. So we're not multiplying by acceleration due to gravity. So we have 350 multiplied by our distance. Remember our distance is cm. We have to convert it to what? M, meter, which is the SI unit of distance. Cm is not SI unit. And remember that 100 cm gives us what? 1 m. So if 100 cm gives us 1 m, what will 10 cm give us? So 10 cm will now give us 10 multiplied by 1 all over 100, which is equal to what? 0.1 m. So if you convert 10 cm to meter, you have a 0.1 meter. Remember that the steps are 20 in numbers. You have to multiply them by 20 steps, which is equal to 20 steps multiplied by 0.1 all over 10 seconds. All of them are 10. The time taken is 10 seconds. So we have to do what? Cancel out. So if we cancel out, we can go like this or can go like this anyway. Remember that this 0.1 is the same thing as 1 over 10. I don't want to use calculator. So I have 35 times 20 times 1 over 10. Wherever you see point, call it 1. I want to convert it to fraction so that I can divide through. So wherever you see point, put 1. The next digit becomes 0. So I can now cancel out. So my answer is now 35 multiplied by 2, which is equal to 70 watts. Remember that power is measured in watts. 70 watts or 70 W. So let's quickly go to what I have to do for you. I will simply talk a little by next week. I'll now come fully because I'll use some of my time in doing correction for you. So I want us to look at the topic on the board, elements, compounds, and mixtures. You know that you soon write your best set and you move to senior class, where this your basic science will be divided into 3 different subjects, which are biology, chemistry, physics. These 3 subjects that are there in senior class. So by next soon you enter into senior class. So we want to introduce you to some of the topics that you will do when you enter JSS1. So let's begin by the word element. What do we mean by an element? Definition of an element. An element is a substance which cannot be split into simpler units by an ordinary chemical process. An element is a substance which cannot be split into simpler units by an ordinary chemical process. Let me come again. An element is a substance which cannot be split into simpler units by an ordinary chemical process. An element is a substance which has a chemical process. What we mean that whatever that is called an element, you cannot easily separate it into its other constituents or simpler units by just an ordinary process. No, it's not possible. Instead, if you want to separate them, you find a chemical means, a chemical process. Scientists have discovered over 100 elements. Scientists have discovered more than 100 elements. We have familiar one, examples of familiar one. We have familiar ones like hydrogen, helium, oxygen, carbon, nitrogen, phosphorus, sodium, iron, etc. These are examples of familiar ones that we call you. We can even put aluminium. These are the ones you can easily find. You can even put magnesium. Then we have more familiar ones that I will call now that you may ask, are these ones also elements? Yes, they are. Unfamiliar ones, you hardly find this one. Familiar ones, we have rubidium, actinium. We have xenon. We have radon, uranium, these are unfamiliar words. They ask me, do this one, that we have not heard of them. Yes, they are unfamiliar words. These elements are found on the Earth's crust. They are found on the Earth's crust, either in the air. They are found on the Earth's crust, that is. So found some in the air, like oxygen and nitrogen are the one you find in the air. Some of them are found in the sea. The one you can find in the sea is we have a sodium. You find it in the sea. This one we call it the salt water. Then elements constitute the building units of all other substances. There is nothing that is in this world that is not made up of elements. Even you, human being, we are made up of many elements combined together. So, elements constitute the building units of all other substances. Those substances that are built up of elements are known as compounds. But before I talk about compounds, let me tell you that these elements you see, about over 100 of them are grouped. We have groups of elements. They are grouped into different groups. So these 100 and something, about 106 elements are discovered, or even more than that now. They are grouped into what we call metals. Then we have the semi-metals or metalloids, if you don't want to call them semi-metals. You don't want to call them semi-metals, call them metalloids. Then we have the non-metals. These are the three main groups we can put elements into. We can group elements into metals, semi-metals or metalloids, then the non-metals. If you go to what we call periodic table, when you come to JSS3, your teacher, your chemistry teacher will introduce you to periodic table. You see another group where these elements are put into what we call transition metal. We have the actinide series, we have the lanthanide series, about 6 groups are there. We have even the rare gases there. We also have the radioactive metals there. We have many of the about 6 groups there, but I don't want to introduce you there. Just know that metals, and your level now, that metals are grouped into 3, and elements are grouped into 3, metals, semi-metals or metalloids, then non-metals. Then, and I told you that these elements constitute the building units of all other substances, and those substances which are built up of elements are known as a compound. And let me now tell you what a compound is, and we call it a day. What is a compound? A compound is a substance which contains two or more elements chemically combined together. A compound is a substance which contains two or more elements chemically combined together. Compound is a substance which contains two or more elements chemically combined together. A compound is formed as a result of a chemical change, and in it a new substance with entirely different properties from those of the substance from which it was formed or its components, elements. What are we saying? Compounds are the building blocks of elements. Elements come together, join themselves, or mix themselves to form compounds. And when they form compounds, what we get as the product is quite different from what we see at the initial stage. That is why we said that a compound is formed as a result of what? A chemical change. You know what a chemical change is? We said that a chemical change is one in which a new substance is formed. And it is not easily reversible. You cannot easily reverse it because you have formed a new substance altogether. For instance, if you use firewood to cook, you know that when you go inside the bush to cut the wood, it is wood. But by the time you put it in fire and use it to cook, those will turn into ash. And there is no way that ash will come back and give you wood again. No. Instead, what you have is ash and charcoal. You cannot get that your wood back. That is what we are saying. For instance, I will give you examples of compounds. When I come next time, I will tell you how they form, how they mix to form. We have examples of compounds. For instance, water. Water is a compound. We have sand as a compound. When I come next, I'll tell you the constituents. We have a limestone as a compound. We have a sugar as a compound. We have common salt as a compound. We have ethanol as a compound. We have the constituents of these compounds. And I'll now give you the formula, the chemical formula of this compound. Hope you enjoy my class this afternoon. God bless you for paying attention.